Welcome to another video from IT Sec Hub. Today we are going to see why HTTP websites are prone to hacking. So what is HTTP? HTTP stands for Hypertext Transfer Protocol. It is in the layer 7 of ISO OSI model, that is the application layer. We use this to present information in a web page, maybe through Firefox or Google Chrome, in a given order and transmit it over a network. If you take a web page in old days, it was really with HTTP. But due to vulnerability issues with HTTP, HTTPS was introduced. So HTTPS is the same HTTP but encrypted with TLS or SSL for securing the transmitting content. But why are we securing them? What is the problem with HTTP? Well, in HTTP, everything that goes over the network or the internet is in plain text or clear text. So it is very easy for a person who knows the subject to tamper it and see the content. Now, especially if you are sending confidential details like credit card details or username or password, so you can imagine what happens when they are leaked to another party. So hackers are good in for searching websites that works with HTTP and extracting such valuable information. Now here you can see the HTTP request and response in clear text. The username and the password are in clear text. So now we will see how this is possible. We will analyze HTTP packets through wireshark. So we'll open wireshark. And then we'll move to Firefox. This is one of web page that I have created to demonstrate how HTTP works. This has a form to enter username and password and transmitting the request to the web server for the login purposes. Now you can see there's a cross for this padlock, and if you move the cursor there, you can see the connection is not secure. So that means you have the HTTP connection instead of a HTTPS. If this is HTTPS, there would not have been a cross. So this is a login page. It allows to type the username and the password, and once the login button is clicked, it transmits the credentials to a web server. So we'll analyze the source code first. Now it has a form. The method used for the submission is post, and the request is transmitted to the web server, and the login POP.php is accepting these requests. And it has two fields. One field is for the username, the other field is for the password. So these are the field names. So it has the login button to submit the inputs. So we'll move to Wireshark now. We have selected the ETH0 as the network interface, and we will start capturing packets now. Now coming back to Firefox and coming back to the system, we'll enter username and password. So we'll type username as user and the password as 123. So these are not actual credentials. So we'll go back to the Wireshark and stop packet capturing. Now it has plenty of records. We'll filter for HTTP packets only. We'll type HTTP and press enter. So it will give you 3 records. So the first record. Now the source is 192.168.8.158. So this is my IP address. Then the destination. It is the web server. So its IP address is 192.168.8.103. The protocol is HTTP. And you can see under the information the post method is given, as well as the login proc.php. So we'll select this and we'll go to the HTML form URL encoded message and expand it. So you can see the form item. This is the text field name, the username, and the value for the text field, its user. So the second text field is password and the value for it is 123. So these are the values that we key when enter into the system. So both values are in clear text. So these can be the credentials of your online bank account, or maybe the credit card details, or maybe some valuable information. So if these are actuals and they are exposed to a hacker, then you are gone. Now to prevent this with HTTPS, all these contents are encrypted. And when a hacker tampered the connection and gets the data, what he sees is a jargon. So he can't understand what it is. So the whole concept behind the HTTPS is that. Now the S in HTTPS, it is for the secure. HTTPS uses TLS or SSL for enforcing the security. For more details about TLS, please watch my video on TLS 1.2 with Wireshark. Now you have the web browser. So it has data with HTTP and it is to be transmitted to the web server. So before the transmission, HTTP data is encrypted with TLS and transmitted. So even a hacker tampered the connection and tried to get this data, he can't understand what it is. He only sees a jargon. So if he has the key, he can decrypt it and understand what it is. So I have converted my web server into HTTPS by installing and configuring a TLS certificate. For more details on installing and configuring TLS certificate in a web server, you can watch my other video on Uncover the secret to installing OpenSSL for WAMP. So this will detail installing and configuring OpenSSL in your web server to work with HTTPS. Now you can see the same web page is working with HTTPS. Here the padlock is there. So you have a warning here. This warning is given because I have used a self-sign-in certificate from OpenSSL. Now we will enable packet capturing in Wireshark. We'll go to Firefox and in the application we'll enter the user credentials. User as the username and for the password it's 123. Of course these are incorrect credentials and we'll click on login. And you can stop packet capturing in Wireshark now. If there is any HTTP packets, we can filter for them and identify. This shows that there is no packets for HTTP. So let's see whether there are packets for HTTPS. So the Wireshark does not recognize HTTPS. HTTPS is generated by encrypting HTTP data using TLS handshake. So we need to filter for TLS in Wireshark. So there are plenty of records. We will extend this filter for the server's IP address. Now if you take this record, it says the source address is 192.168.8.158. This is my browser's IP address. So the web server is 192.168.8.103. And after that, you can see there's a record for application data. So this is an encrypted message sent by the web browser to the web server. So this is the message that we are transmitting, the username and the password. Above this application data message, you can see 4 records. So those are the record numbers from 46 to 50. Now these records are belongs to the TLS 1.2 handshake. Now the record number 46. This is the initial message sent by the web browser or the client to the web server. So it is the client hello message. So this includes the list of cyber suites that the client is capable of handling, as well as a random number and the TLS version. So once it is received by the server, Server sends its TLS version and the selected cybersuite out of the list that the client has sent and the random number along with the certificate of the server and some server key exchange details. In response to the server hello message, the client generates a session key for future encryption, and as a confirmation, client sends the finished message by encrypting with the session key. And then once server receives it, server also generates the session key and send the finished message to the client by encrypting using the session key. So these 4 records are for the TLS 1.2 handshake. The very next record is for the application data. So all these data are sent by encrypting with the session key. So the very next record is for the username and the password. So if you want to get more details on TLS 1.2, you can watch my other video on TLS 1.2 handshake process explained with wireshark through ITSec Hub. If you click on application data, you can see the transport layer security in the second pane. We'll expand it, and this says the application data protocol is HTTP over TLS. That means the HTTP data is encrypted using the session key generated at the TLS handshake process. So you can see the encrypted application data. In Wireshark, there's another pane that we can see this in detail. So we'll go to Edit, then Preferences, and Layout. So this is for the first pane, and this is for the second pane, and this is for the third pane. So we will enable packet bytes in pane 3. Now you can clearly see all these data are not in a readable format. It's a jargon. So if you click on this, you can see all the data is encrypted and not in plain text. So your confidential data like credit card details or username passwords are not exposed to another party. Now TLS uses a technology called public key cryptography. There are 2 keys, a public key and a private key. And the public key is shared with the client device via the server's SSL certificate. So when a client opens a connection with the server, the 2 devices use the public and the private key to agree on new keys. So these are called session keys. So this will be used to encrypt future communications between them. All HTTP requests and responses are then encrypted with these session keys so that anyone who intercepts the communication can only see a random string of characters. But there are still some vulnerabilities in TLS 1.2. So the TLS 1.3 came into action in 2018, but still some web servers are not upgraded their TLS version to 1.3. So we will meet with another video on TLS 1.3. Please stay tuned with ITSec Hub.